For notes number 19, we're going to be finding the volume and surface area of rectangular prisms. So what is a rectangular prism? It's a three-dimensional figure, meaning it has three dimensions, length, width, and height, and all of the surfaces are rectangles. So here's a picture of a rectangular prism where all of the surfaces are rectangles, the six different sides, and it's three-dimensional. It has length, width, and height. So volume is how much space it takes up, as if you were filling this with water. And then the surface area is the area of all of the surfaces. Since this rectangular prism has six different faces, you would have to find the area of all six different sides, as if you were wrapping a present. So you would need to know how much wrapping paper you would need to cover all of the six surfaces. So for 1 through 3, this should be fairly easy. You're finding the volume of each rectangular prism. So the volume has a formula. You're just multiplying length times width times height. And it does not matter what you choose for length, width, and height. In this picture, they chose L, the length, to be 8. They chose the width to be 4, and then the height 6. It does not matter because if you multiply three numbers, it doesn't matter the order. You get the same answer no matter what order you choose to multiply them. So really, you just need the three dimensions, and then you're just multiplying those answers together. And since you have 8 centimeters times 4 centimeters times 6 centimeters, notice that volume has the units to the third power, or cubed. So in this first picture, I would have 9 centimeters times 17 centimeters times 24 centimeters. So if I multiply 9 times 17 times 24, I get 3,672 centimeters cubed. So again, volume, you just multiply the three dimensions together. In the next picture, 10 inches times 14 inches times 4.5. So if you multiply 10 times 14 times 4.5, I get 630 inches cubed. For the last one, I have 39 feet times 8 feet times 12 feet. So if I multiply these three numbers together, I get 3,744 feet cubed. So for part 2, it's a challenge to try to devise the formula for surface area of a rectangular prism. So if I look at this picture, I already see that the surface area, since this rectangular prism has 6 different faces, it's broken up into pairs here. So this first pair is the top and bottom. They should have the exact same area. The next pair is the front and back face of this rectangular prism, which should also have the same area. And then the third pair is the left and right side, which should also have the same area. So technically, since the surface area is the total of all of the surfaces, I just have to add these 6 numbers together, and that would give me the total surface area of this rectangular prism. So I'm going to use some colors in order to differentiate the 3 pairs. So for the top and bottom. So I'm going to trace this top here. So the top and bottom will be in red. So if I look at the dimensions, this would be 8 inches and this would be 17 inches. So the top and bottom would be 8 by 17. Since it's a rectangle, you multiply length times width. So I'm going to switch colors here. The front and back. So I'm going to trace the front here. So the front and back will be in purple. So the dimensions would be 17 by 12, right? Here's the length. Here's the width. So 17 by 12. And then lastly, switching colors here, I'm going to trace the left and right side in green. So here is the left side. So the dimensions would be 8 by 12. So 8 by 12. All right, so I'm ready to find the area of all 3 pairs. So the very first pair in red is the top and bottom. So that was 8 by 17. So 8 by 17, if I multiply that together, I get 136. So that's for one rectangle. Then I'm going to find the area of the purple, which was 17 by 12. So if I multiply 17 by 12, I would get 204. And then the green rectangle's area, 8 by 12. If I multiply 8 and 12, I get 96. So to find the total surface area, again, what does the surface area represent? It represents the area of all 6 faces. So what I have so far in this list is 3 of the faces, right? So 136 inches squared, if I multiply 8 inches by 17 inches, that represents only the top, right? However, there's also the bottom, which is exactly the same. So I just have to double 136, right? So far that takes care of the first pair. The second pair, the front and the back side, has an area of 204 square inches, but there's 2 of those. There's the front side and then there's the back side. So if I double 204, that will take care of both the front and the back. And then there's one final pair, which is 96 square inches to represent one of the rectangles here for the left and the right side. But again, since there's 2 of those, I have to double 96. So if you multiply 2 times 136 plus double 204 plus double 96, you get a total of 872 square inches. So this is the total surface area. So let's recollect our thoughts and try to write a formula for the surface area. We already know volume is length times width times height. So for the surface area, I'm going to give these numbers some variables. So the 3 dimensions were 8 by 17 by 12, right? So I'm going to say 8 is the length. I'm going to say 17 is the width. And 12 is the height. So in the formula, instead of 8, 17, and 12, I'm going to use generic variables, length, width, and height. So let's take a look at what we did for this first part. So to get 2 times 136, we multiplied 2 times 8 times 17, right? So the 8 times the 17 would be length times width. So 2 times length times width plus, how did I get 2 times 104? So 2 times what? How did I get 204? So to get 204, I multiplied 17 and 12. So 17 is the width and 12 is the height. Lastly, how did I get 2 times 96? How did I get 96? So I multiplied 8 and 12. 8 is the length, 12 is the height. So this essentially is the formula in order to find the surface area of any rectangular prism. However, I kind of use a different pattern than having to write out this formula every single time, and I'll show you in the next example. So for the first figure, we have a rectangular prism. So the volume, you're just multiplying the 3 dimensions together in any order. So 7 feet times 13 feet times 9 feet. So if I multiply that together, I get 819 feet cubed. For surface area, you could label 7 as your length, 13 as your width, and 9 as your height. And again, it doesn't matter which one I chose for length, width, and height. You would get the same answer. And then you could plug into the formula that we discussed previously. However, I think there's an easier way to do this instead of labeling length, width, and height. So what I do is I set up the formula as you see here. So you're doubling the first pair, which is the top and bottom. You're doubling the second pair, front and back, and then doubling the third pair, left and right. So once you set up the formula, all you have to do is pick a pair of numbers in the picture, any pair. So I'm going to start with 7 and 13. So 7 by 13 will be my first pair. In the second parenthesis, instead of pairing 7 and 13 together, so 7 was already paired with the 13, I'm going to pair the 7 and the 9 together. So instead of 7 and 13, I'm sticking with the 7 and pairing it with the 9 next. Once you pair the 7s together with the 13 and the 9, 7 has already been used twice now, and so the last pair would be the 13 by 9. So again, start with any number, say 7, and pair it with the 13, then pair the 7 with the 9, and you could think of it like crossing out the 7s because we already paired those together, and the remaining pairs of 13 and the 9. All right, so from here we're just multiplying. So 2 times 7 times 13 is 182 square feet. How come it's only feet squared? It's because we have 7 feet times 13 feet. The 2 does not have units attached. You're just doubling that since there was a top and a bottom. The next parenthesis, 2 times 7 times 9 is 126 square feet. And then 2 times 13 times 9 is 234 square feet. So if I add these three numbers together, I get 542 square feet. For the next rectangular prism, volume is easy. You're just multiplying the three dimensions in any order, 10 times 16 times 5. So if I multiply this together, I get 800 centimeters cubed because it's centimeters times centimeters times centimeters. Surface area, the area of all 6 surfaces added together. I'm going to set up this formula like we did in the previous. Pick a pair to start. So if I choose 10 and then 16, that will be my first parenthesis. So 10 by 16. So I'm sticking with 10. 10 was paired with 16. Now it's going to be paired with the 5. So 10 by 5. So 10 is done. It got paired already twice. And the very last pair would be the 5 by 16. And it doesn't matter what pair you start with. You get the exact same answer. So if I multiply 2 times 10 times 16, this would be 320 centimeters squared. Again, 10 centimeters times 16 centimeters becomes centimeters squared. If I multiply 2 times 10 times 5, I get 100 centimeters squared. 2 times 5 times 16 would be 160 centimeters squared. So if I add those three numbers together, the total surface area of all 6 surfaces is 580 centimeters squared. For the back side of the notes, you're going to be applying area and volume. And in this scenario, it's a house flipping application in which if you're flipping a house, you're buying a house that needs, for instance, it might need paint, it might need a new air conditioning unit, it might need new tile, it might need exterior work. And in this scenario, we're going to be repainting some of the rooms and we're going to be putting in a air conditioning unit and finding out the cost of that. So for this first part, we are given a picture of the dimensions here of the master bathroom and master bedroom. And the house that we bought here needs repainting in those rooms. And we're going to be asking how much it's going to cost and how many cans of paint we're going to need. So here's our scenario. The walls are 10 feet high and we're not going to be painting the ceiling. So the paint costs $25 per gallon and 1 gallon covers 350 square feet. So how many cans are we going to need? Well, first we need to figure out our total area calculations of what we're painting. So looking at the master bathroom, it has 5 walls. We have the 16 feet here, 10 feet, 2 feet, 11, and if this is 10, then this has to be 10 feet as well. So we're going to be painting those walls, and the walls are 2-dimensional. It says that they're 10 feet high, so you could think of it like this is right here, this 10, and the wall goes up, so you're painting a 10 by 10 wall here. So we're going to list the walls here. So this first wall, a 16 by 10. The next wall, I'm just going to circle these. So 16 by 10. The next wall, 10 by 10. This next wall here, 2 by 10. The reason there's an open space is because that's for a door. So this next wall is 11 by 10. And then the final wall here, 10 by 10. All right, so let's find the area of all 5 of these. So 16 by 10 is 160 square feet. 10 by 10 is 100 square feet. 2 by 10 is 20 square feet. 11 by 10 is 110 square feet. And 10 by 10 is 100 square feet. So if we total these together, how many square feet total are we painting so far? If we add these 5 numbers, you would get 490 square feet. So that's to paint the master bathroom. Let's move on to the master bedroom. There's 5 walls. So I'm going to circle the 5 walls that we're painting. We're going to be painting this 11-foot wall, this 2-foot wall, this 18-foot wall, this 15-foot wall, and this one is blank. However, if I shift to the top here, all the way across here, that's 16 feet. All right, so I'm going to list my numbers. 11 by 10, 2 by 10, 18 by 10, 16 by 10, and then 15 by 10. So if I multiply these, 110 square feet, 20 square feet, 180 square feet, 160 square feet, and then 150 square feet. So if I add these 5 numbers together, I get 620 square feet. So in total, I need to take these 2 numbers here and add them together. So how many square feet am I actually painting? 1,110 square feet. All right, so that's how much we're painting. So let's take a look at what we're given. 1 gallon covers 350 square feet. So 1 gallon covers 350 square feet. I'm trying to figure out how many gallons I need when I'm painting 1,110 square feet, right? So cross multiply. 350 times x is 350x, and that's equal to 1 times 1,110 is 1,110. Divide both sides by 350. So let's see, 1,110 divided by 350. I get 3.17, blah, 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 blah. So approximately 3.2 if you round to the nearest tenth. So we need more than 3 cans, right? We need 2/10 more. So that means we need to round up to 4 cans. So we need 4 cans of paint to paint this. And then how much is it going to cost? $25 per gallon. So if we need 4 of those, if I multiply that by $25 per gallon, right, we would get $100. So it's going to cost $100 in order to paint the master bathroom and bedroom. Lastly, we are asked to pick an air conditioning unit if we're going to replace the air conditioning in the master bedroom. So if you think of the master bedroom, a rectangular prism here, okay? The dimensions are, 18 by 16. Let me finish my cube here. So 18 by 16. And then the height, the ceilings are 10 feet high. It tells us right here, the ceilings are 10 feet high. So we're going to be replacing the air conditioning, which cools the entire space, right? So that would be the volume of the master bedroom. So let's see what the volume is. 10 by 18 by 16 volume, you're multiplying all 3 numbers together, right? So 10 by 18 by 16, if you multiply those 3 numbers together, you get 2,880 cubic feet. So that's how much space we're going to be cooling. So which unit are we going to buy? Well, we need more than 2,000, right? Because we have 2,880. So we're going to need the $150 unit because that cools 3,000 cubic feet.